Hello everybody. In this work we present Shamir's secret sharing algorithm in Leo. But Leo has some limitations. It doesn't allow the users to play with variable sized arrays, or it doesn't allow you to index a given array using variables. And it also has some limitations over the number of maximum transition functions that you can have in a given contract. And these constraints prevented us to implement a fine-grained, a fully a fine-grained version of Shamir's secret sharing algorithm in Leo due to these limitations, as I stated. So instead, we went with the approach of writing JavaScript code that generates Leo code for the given parameters. And because the user can choose to split their secret into 10 pieces, maybe 20 pieces, so ranges from 2 to 32. But again, Leo would not allow that, so we came up with this approach of writing JavaScript code that outputs Leo code. And to be able to interact with the build, one first needs to install bun and then do a bun install. And then the commands that allows the users to interact with this build are put into package.json. And we have a bunch of scripts here, mainly the generation, the splitting and recovery functions. So to be able to split a given secret, first we need to generate the code that actually splits that secret. And for that, we will use bungen. The first parameter n will, well, if you make it 10, you will get 10 evaluations of your secret polynomial. And k is how many of those evaluations you will require to reconstruct the secret. So a combination of 10 and 5 is going to generate a degree 4 polynomial, and you will need 5 evaluations of a degree 4 polynomial to build it fully. And then it will also evaluate that polynomial at 10 points and give you the evaluations. Let's generate the code that does this, and then let's also go and investigate that code. So as you see, it consists of a recover function and a split function and a Horner function. As you see, it returns like 10 evaluations padded with zeros and stuff. If these parameters were different, let's make them like, I don't know, 45 to 20. The code would change and it would output the corresponding code. So let's actually go with 45 and 20. And then we need to feed in input to this program. So what we can do is we can do bun split, which is going to call Leo run split, literally. Bun split some secret, and the secret should be a field element. And then once we go with this, it is going to evaluate our secret polynomial at 45 points, out of which 20 will be required to reconstruct the secret. So let's grab the first 20. And we need to put these into the input file. It's like in the input /Shamir in. And here we just need to put the evaluations that we have taken. Let's take from 1 to 21 actually. And then we will just need to call the recover functionality. Let's go bun recover. And it is going to output back the given secret. And let's also, I don't know, change 2 evaluations randomly and see if it's going to work. Maybe substitute these and then call bun recover again. So as you see, it doesn't matter which evaluation you use. So yes, we have tried to challenge. Let's also run the tests together. We have implemented some test cases. So we are trying to challenge the limitations of the Leo language to come up with a flexible implementation of Shamir's secret sharing.